Welcome to Short Talks from the Hill, a podcast from the University of Arkansas. I'm Harn Young, a research and economic development writer. Today I want to welcome Scott Lafontaine, an assistant professor in food chemistry. Generally, his research interests include understanding the important chemical drivers of aroma, taste, and mouthfeel, which define food and beverage quality, and how different factors influence these analytes in value-added products like beer, wine, sake, and other non-alcoholic drinks. Some of this research has taken the form of studying whether rice might be used to improve the quality and acceptance of non-alcoholic beer. Lafontaine is also co-director of the UA Certificate of Proficiency in Brewing, which includes a nanobrewery housed at the U of A Beverage Development Facility. Scott Lafontaine, thanks for doing Short Talks.
It's great to be here.
Can you tell us a little bit about your research into using rice as a base ingredient for beer?
I joined the university about a year and a half ago, but what brought me here in terms of creating a program was the rice industry. I have brewing science in my background. Technically, I'm an analytical chemist. And so what that means is I sort of break apart raw materials into their molecular components, and we use that data to sort of either grow that material, breed that material, and leverage that material to make value-added products. And for me, I've worked with brewing. And so rice is a very important part to the economic, agricultural status of Arkansas. And so that's what drew me to here. And rice is used in brewing, right?
Sure.
It has been used as a raw material in brewing for a long time. What's going on right now in the brewing industry is we see explosive growth in non-alcoholic beer. Consumers want healthier products. And so barley comes in with certain flavor characteristics that are sometimes negative. In the brewing industry, we call that worty, W-O-R-T-Y. And so that characteristic is sort of like grainy. You can think of it like you took your Cheerios and you put them in water and you drank that water. That's kind of the characteristic, sort of. But it's unfermented sugar grain. That's typically how non-alcoholic beers were made. And what we're thinking is basically by substituting out some of that barley, we can add in rice. And rice has a more neutral character, or some rice varieties do. Some rice actually has, quite aromatic flavor. But in this case, we're looking for that neutral characteristic of rice to bring in and tone down some of that wordy characteristic. And we're finding success with that. It's a little bit more of like an aromatic quality, and typically that unfermented beer would be very sweet. So we're also working on not necessarily just leveraging rice, but also certain techniques to improve non-alcoholic beer flavor too. So I have a PhD student that started in January, and he's leveraging different yeasts that don't necessarily ferment maltose, which is the main disaccharide that's produced in the mashing brewing process that yeast eat to make alcohol. So there are certain yeasts that don't ferment maltose. We call those maltose negative, as well as another handful of yeast that don't assimilate, maybe certain sugars or non-sac or, different organisms. And they can be used to create fermentative flavors, but not alcohol. So we're kind of looking at this at all approaches. So we're leveraging rice to sort of dial back that wordy character, but we're also looking at, how can we leverage, maybe different organisms or different process techniques to also create preferable NAB quality.
Can you tell us a little bit about the Certificate of Proficiency in Brewing?
The certificate in proficiency in brewing, that was created sort of around COVID in 2020. And that program basically is a 9 major credit core course. We have a theory course, which is brewing science. We have a production course, which, students are getting in and they're using that theory to design different grain-related products. It doesn't have to necessarily be non-alcoholic, but it could. But it's really them learning how to take raw material specifications, use those, design a beer from start to end, and then analyze that as well so they can become like maybe quality analysts. And then the last piece of that is an internship. So those are 3 credit hour courses, and then there's 6 credit hours that the student has to have that are electives. And a lot of those electives cater to certain degree programs. So for example, engineering, food science, chemistry, microbiology, a lot of those core courses that are taken in those degrees can supplement in for those electives.
Yeah, I was curious if it was just food science students or if more people were coming into that program.
It is a collection. So I've taught brewing science now for 2 years, and I would say about maybe a quarter of the students are food science, but then the other proportions are engineering, micro, chemistry. It's this melting pot of students, and that's really because brewing it's leveraging all these different disciplines.
What's the capacity for this class?
I would say at least the production class in the space that we have right now, we're limited to about 20.
And are you offering it each semester, or is it like in the fall or the spring?
The brewing science course is offered in the fall. That's that theory course where we learn to build the recipes, and then the brewing production would be in the spring.
Beer is not your only area of interest, so what's another product that you're working on?
Yeah, so we have a major USDA grant with blackberries. So really, right, we're leveraging that analytical chemistry to improve crops or value-added products. And so we're working with Dr. Renee Threlfall and Dr. Margaret Worthington to sort of analyze the aroma profiles of the advanced lines of blackberries that we have. And we're linking that to consumer liking. And the goal is if we can tune the genetics to produce the type of chemistry we want in these berries, then we can design berries quicker that have preferred flavors. These are our local Arkansas blackberries. These are being grown right down in Clarksville.
You are also working towards the establishment of a Center for Brewing Innovation. So can you kind of tell us about where you are with that and where do you want to be?
Yeah, I'm really excited about this. And I think there's huge potential in this area to become a leader in beverage technology from a research and education perspective. And where we want to be, right? So we've got some exciting news. We're moving forward with a brand new food science building, and the funds are allotted for that. And the goal is to have this building move-in ready by summer 2026. The vision is to have a center for beverage innovation sort of housed within that building as well. And the goal would be to have a production facility, which would be a state-of-the-art production facility that could be used to design a number of different products, right? The goal is beverages here, and beverages that are important to Arkansas. So that could be non-alcoholic beer, that could be sake or other different rice-based beverages, maybe even rice milk. Then we would have a flavor characterization lab, and then a consumer data-driven tasting area where we could get consumer feedback, let's say on our own R&D projects or like our commercial partners' products in real time. That right now we're sort of in the funding generation stage. And so we have ideas about what we want in these spaces, but we're still trying to build that out. And why I think this area is because innovation is important to, at least from what I've seen so far in Arkansas, we're innovators and we're really sort of leveraging our commercial industry partners as well as the success at the University of Arkansas to be leaders in that space on a global perspective.
So you mentioned there were 3 components to the center, and flavor characterization was one of them. Can you talk a little bit about what kind of goes into the science of flavor characterization?
Yeah, I think in terms of research, that sort of is where I find, I'm an analytical chemist, so it's really important for us to sort of lead by research and really that molecular level understanding of raw materials and sort of the value add and what drives their quality from a flavor perspective that really allows us to be a leader in this space. And what we're doing in there is we have instrumentation. We're using gas chromatography or liquid chromatography. Gas chromatography is like your nose, and liquid chromatography would be, sort of like your tongue. And so we have these instruments that can measure different analytes and characterize the qualities that we're looking for, that drive taste and aroma.
So are these flavors arrived at through like breeding? Like if we're talking about blackberries, is it through like interbreeding or breeding different types of blackberries? Or are they arrived at through, I guess, more artificial means?
Back in that yeast project, we can just go out and we can collect yeast, right? And there's a professor here that has a yeast data bank, and we can just look at sort of yeast that exist. But there are companies that are sort of using CRISPR-Cas9 to take, let's say, the basil genome and put it in a yeast, and that yeast now produces sort of a hoppy-like character. And so we can leverage this technology to really understand sort of what flavors we want. And now as we get better technology, we can make this process go quicker. So it takes about, 10 years to get a blackberry variety. And so if we can work to understand what the characteristics we want in those varieties, we can help to speed up that process and define, the traits that we're looking for in blackberries or rice. The other piece of this, too, is it also depends on how you grow that material. And so how long that material ripens, when to pick it, depending on whether or not you have the ability as a farmer to sort of adjust those parameters based upon the size of your farm. This type of instrumentation can be leveraged to help with that understanding as well. And then finally, we get in the brewery, that processing equipment. You can also, by understanding the molecular composition, change how you process that material. And so I've worked on, with all three of those, the way in which you attack the problem can be at each of those directions. And it's really about having great collaborators, which at the University of Arkansas, there's been a number of great people to work with.
The nature of what you're trying to accomplish, that you will be looking for corporate partners that you can work with projects on to make sure that maybe you can assist them with improving their products or working with them to develop new products. Would that be part of the plan and what you're trying to do?
Without a doubt. So we have this research component, right? We have the education component, and we also have a little bit of a service component. The USDA supported equipment grant. And so one of the equipments, our gas chromatograph, it's, I would say, a fairly unique instrument for the area. There's probably not something like it within a 250-mile radius. And so from an instrumentation perspective, it's a very high-level instrument. It allows us to do some pretty sophisticated work. And we are already leveraging that to do some service projects and, collaboration research projects with industry. That also sort of opens us up too, right? We're working on pet food. We're working on other products that sort of from a flavor perspective, the molecules can kind of be the same as you go between different things, but the concentrations vary. The instrumentation is very flexible because it can be used in a number of different approaches. And I've been finding it quite nice because, I'm new to the area, so I'm learning sort of the products that are important and the spaces that need help.
And what should be on our radar after rice and blackberries? Anything else?
I think pet food for sure. In terms of what's coming up, we have a large collaborative project that we'll hear about funding soon, and that would be muscadine. And muscadines are really interesting from a flavor perspective. Again, I grew up on the East Coast, and so the first muscadine I had was about a half a year ago. The variation in flavor that you can get from that fruit is quite amazing. I would say that would be the next big target.
Thanks. That sounds great. Scott Lafontaine, thank you for coming in today.
It's been a pleasure. Thanks for having me.
Short Talks from the Hill is now available wherever you get your podcasts. For more information and additional podcasts, visit arkansasresearch.uark.edu, the home of research and economic development news at the University of Arkansas. Music for Short Talks from the Hill was written and performed by local musician Ben Harris.